Yes, I'm Dave Verwer, and I'm going to explain to you today how I accidentally started the largest open source Vapor website. The site in question, as you might imagine, is the Swift package index. But let's dig into that title for a second, because there's a couple of things which are probably making you stop for a second in that title. What does largest open source Vapor even mean? Is it number of lines of code, number of commits, how many people visit it? There's lots of Vapor being built closed source inside companies. I know lots of companies are using it, but there's actually not that many open source website projects built in Vapor. In fact, it may be a field of one. And if you narrow down, if you narrow it down, you can win at anything. The other word that you might have raised an eyebrow at is the word accidentally. Did I trip and on my way down type Vapor new? That's not how it happened. That's not how it happened. Let's talk about how it did happen. So the first time I thought about making some kind of package index type project was actually back in 2016 at the WWDC conference there. That year there were some Swift Package Manager announcements. At the time, it didn't support building iOS or macOS projects. But I knew that that project was on a path where it would eventually, to me at least, it seemed obvious that it would eventually become a dominant package manager. And at the time, CocoaPods was absolutely dominant in that area for iOS and macOS applications. But CocoaPods was both, or is both, a package manager and also a package search engine. The two things are combined. And I thought forward a few years, and I thought, well, at the point where Swift Package Manager, it clearly is not going to include a package index, so there's potential for a package index project back then. It was a few years before I actually ended up doing anything about it, but the idea had been floating around in my head for quite a while. Before we go any further, I do have a bit of a secret. I've written many web backends for both as websites and also as backends for iOS and macOS apps over the years, and I tend to build them all in Rails. That's been my framework of choice. The door's at the back there if anyone wants to leave. We're not going to talk about Rails today, but this was certainly my choice. You know, lots of both web applications and APIs in Rails itself, but also static sites using Jekyll. It was always the tool that I would reach for when thinking about doing something on the server. I quite like the Ruby language, and Rails is a robust, stable, battle-tested framework. It was a sensible choice. And so in 2019, when I thought, well, now's maybe the time to actually make some kind of package index, Rails was what I reached for. And this is the first incarnation of what became the Swift package index. It was called the SwiftPM library, and it was a single-page application that was Jekyll and Vue.js on the front end, and a Rails API server on the back end. But it did have the same fundamental basic idea as what now runs in the Swift package index, which is it would constantly poll a set of known packages. It would pull the package repositories down, and it would run package dump package on the repository to get a JSON representation of the metadata inside the package. And it would store all of that along with a whole load of stuff from GitHub and various other online sources. It would store all that in a database and allow it to be queried. And that launched in August 2019. A few months later, I got an email from Sven Schmidt, who at the time had written a small utility to take a Swift package and prepare a playground that already imported that package. And he'd looked at SwiftPM library and wondered whether there might be a button next to each of the packages where you could click that button and open up a playground that already imported that package. This is Sven, by the way, and just in case you need a key to that diagram, this is Sven and this is Taz. Taz is also heavily involved in the package index, but he doesn't like to take much credit, so he leaves that to myself and Sven. So Sven and I got chatting, and I'd also been having some discussions with various members of the Vapor Discord. They had also had the idea to do maybe a packaged index type site, but to write it in Swift using Vapor and to do it as open source. So we'd been chatting, Sven and I got chatting, and we decided that if this was truly to become a true community resource, that making it open source and writing it in Swift, certainly it wouldn't have got a lot of contributions if it was still written in Ruby today, given that the community that use it are all Swift developers. So it made sense to do it as open source, and it made sense to do it in Swift. And so we kind of started over. We took the basic architecture of what the SwiftPM library did, but we joined forces. Sven was already familiar with Vapor, had used it in some projects, so that was a huge win, because at the time I hadn't used it. Yeah, we started building it again. So it wasn't exactly an accident, but it certainly wasn't what I intended when I originally kind of had this idea back in 2016. So what did we build? So Sven and I both care deeply about the package ecosystem. And what we built, or what we at least hope we've built, is something that is more than just a pure metadata dump of all the Swift packages that we could find. And we thought about it, and we thought we really want to help people make better decisions about their package dependencies. It's more than just presenting all of the metadata. It's about highlighting things like how well maintained a package is, how long it's been around, how many contributors it's had, what compatibility is there. And so we really keep this goal in mind as we push features into the package index site. And this is what it looks like. So for a package, in this case the Vapor package, you can straight away see lots of contributors. That's always a good sign. It's been in development for a very long time. That's always a good sign. You can kind of tell when the last maintenance activity was. You can see what license it uses, whether there are major releases, beta releases, or of course just a kind of a branch version. And so we try and highlight all of this information right at the top of the page. And then you'll notice towards the bottom this section, which this little matrix hides an enormous amount of complexity. So when we were starting to think about how to represent compatibility, there's actually somebody else suggested, well, why don't you just build all the packages? And that sounded like a ridiculous idea at the time, but as we thought about it a bit more, we thought, well, why don't we just build all the packages? So what we have is a build system behind the scenes, which for every package runs 24 builds per version. Every time there's a new version released, we run another 24 builds, and every time the main branch or the default branch moves forward, every 24 hours we'll do another set of builds on that. And as they pass and fail, we update our compatibility matrix on top of that. So there's a lot of information hidden behind that little matrix of green ticks. That build system has also allowed us to move other features forward. Like, for example, recently, we've launched docc documentation hosting support. So if the package author puts a configuration file in their repository and tells us which target to build documentation for, at the end of a successful build, we'll then run docc, upload those documentation files to a hosting service, and then present those documentation files on the packages page as a documentation link. But all of that is only part of it as well. there's a lot more to running an open source project than just writing the code and getting it hosted on a server and allowing people to access it. It's about responding to pull requests. It's about, recently we started a podcast where we talk about what we're doing on the development side, and also we do some package recommendations every time. So it's about much more than just writing code, and running an open source project that has contributors, or at least has some attention, is much more than writing code. How far have we got? It's now 2.5 years since we launched the Swift Package Index in June 2020. And we've had 6,500 commits, 1,200 completed pull requests, 500 deployments, that's several every week. There's 5,000 packages now being tracked by the index. By the way, this tool, because I know we're not doing questions, but I know there would be a question about what generated this. The tool is called Gource, Gource, and it's at gource.io. And all you do is you run it in your project directory, and it generates this wonderful animation of your commits, with every contributor being represented by a little person. So that's where we've kind of got to. But as I say, it's about much more than just writing that code and putting it on a server. You really have to take time to deal with issues, deal with discussions, engage with the community, and also just talk about it incessantly. Like, you need to talk about your projects until you're sick and tired of talking about your projects, and then you need to talk about it a little bit more, because it's really hard to get people to pay attention to, well, anything you do. We are open for contributions. We have an issues list, and we also have a discussions forum where if you would like to propose something, you can place ideas into our discussion forum, and we will chat with you about them. So, what's next? We're gaining adoption every day. We've got lots more work to do, both on features, but also adoption, and also as package registries start to. Apple announced a couple of weeks ago that they were going to start development on an open source, community-driven implementation of the package registry. So that will have huge implications on how the package index works as we start to not only look at Git repositories, but also registries that have packages in them. So we've got a lot still to do. And the future of server-side Swift is looking really bright as well. Things have come a long way. When we first started this project, Vapor 4 was in beta. And since then, there's been 160 plus releases of Vapor 4. And I can't even imagine how many releases of all of our dependencies there have been. Honestly, it's the open source environment in which Vapor lives, with Apple building lots of underlying frameworks like Neo, and lots of open source projects that help us build software like this. It's a wonderful ecosystem. We're proud to be a part of it. So the future is bright. And as we also take advantage of things like async await coming into Vapor, it's actually allowed me to understand Vapor a little bit more as well. So I'm much more comfortable writing Vapor code than I was right at the beginning with the event loop features. So that's all I have to say today. Thank you so much for listening, and that's great.